Wow! It's another time that I would like to take this opportunity to have good news that I must transform into advanced secondary students and into the minds of ordinary diploma students in engineering and science. How are you, everybody who is watching this fantastic video? I would like to take this opportunity to thank you who have joined me right now, and I would like to take this opportunity also to welcome you into our interesting online training program. Today we are in Tanzania Online Advanced Secondary School. This is a very fantastic online school where we are teaching science and mathematics students about the beauty of mathematics and science in human life. My name is Olenjolai. I thank God who have given me a gift of teaching, and I would like to take this opportunity to welcome every student who is watching this fantastic video to join us, because today I have prepared the good news about mechanics and about advanced physics. Then we are going to use the Tanzanian physics syllabus or Tanzanian syllabus for secondary schools, for advanced secondary schools. And the particular subject that we are going to I'm going to teach you is about physics. I would like to take this opportunity to also thank God who have given me a gift of teaching and being mathematicians, scientists, and also engineer. And I would like just to be very grateful to him who have given me this special talent. Teaching to me is a work of my heart, and I would like to ask you that, or I would like to tell you in advance, stay connected, because the good news about the beauty of advanced physics is coming in your mind. Then I would like also to take this opportunity just to ask you to be a serious student. This is an online program where we are using the power of the internet to teach the beauty of physics and distribute our contents into all 31 regions of the United Republic of Tanzania. I am a Tanzanian, and I'm very committed to teach about the reality of advanced subjects in Tanzania to the different scientific and mathematics students in our beautiful country. So before we start our today's session, I would like to take this opportunity to welcome you into our online school, where that we have our official YouTube channel that called the Tanzania Online A-Level Secondary School, in square bracket Olenjolai. That's our official YouTube. In this official YouTube, we have almost 6 departments, and one department is called Departments of Advanced Physics, where we are teaching advanced physics for the Form 5 and advanced physics for the Form 6. Welcome also. The subject of the day is called advanced physics. The main topic that I'm going to teach you today is called the mechanics. Say mechanics. And then these contents are prepared specifically for the pre-Form 5 PCM student, PCB students, PMC student, and PGM students, but also are prepared for the Form 5 PCM student, PCB students, PMC students, PGM students. These are the combinations particularly for the students who are pursuing those 4 combinations. P standing for advanced physics, and also this P, this P, this P. So stand for advanced physics. Also, the content that I'm going to teach you in session 6 are covered in different, different colleges and institutions, especially engineering and technical college, and scientific college engineering, technical and scientific colleges. So I'd like to take this opportunity also to welcome you into our Tanzania Online Full Technical College, where we are training ordinary diploma students about just the applications of physics, electronics engineering, basic telecommunication engineering, the kingdom of heavens, etc., etc. So welcome to the departments of mechanical engineering, which acts as one of the departments that teach different modules about mechanics. And today we are in chapter 5. Remember, it's a branch 2 that's called motion in 2 dimensions, and we are going to discuss about chapter 5, which is titled as uniform circular motion. Then, dear students, today I'm going to teach you session 6, which is titled as motion in horizontal cycle. One thing which I want to tell you, that we are here to help or to take complex concepts, break them and make them simpler and simpler, so that you can digest them in order to enjoy and love physics advanced physics for the rest of your life. So I'd like to ask you to be serious, very committed, have your physics for advanced level secondary school books by Tanzania Institute of Education, very important book. Also have your physics syllabus for advanced secondary schools. Have your exercise book, have your pen, have your pencil, have your rubber, have your sharpener, and also have your scientific calculator in order for you to understand and practice every concept that we are going to teach you today. I would like to tell you that this is a very wonderful concept, and it's a practical concept because we are going to discuss about what is motion, motion in horizontal cycle. So our classes are very interactive. We'd like to ask you that to ask questions, give us feedback by using the chat when this video is live, and we give us feedback by using the comment section. Write the comments, just give us feedback, ask questions about uniform circular motion, and all the online students, parents, guardians, teachers, I would like to ask you that to interact with students in the comment section. But also, let's take the opportunity to welcome all teachers who are teaching advanced physics in beautiful country of Tanzania. Use Tanzania Online A-Level Circuit School as the one of the resource. And remember that we've created a playlist that's called the Uniform Circular Motion, where we have taught you almost 5 sessions, and this is session number 6. Session 0, 1, 2, 3, 4, 5, 6 session, and this is session number 7 in case of 40 of counting. So are you ready, my dear students, to take the concept, to take session or to learn motion in horizontal cycle? Yes, that is the kinds of the road noises, but just for a while. So, dear students, now let us discuss the concepts of motion in horizontal cycle. Before we discuss our motion in horizontal cycle, let us do the quick review. Quick review of session. Quick review of session 5. Especially session 4 and the 5. In session 5, or just let's say that from session 1 to session 4, I've been teaching you about session 1 to session 4. We'll be discussing about parameters of uniform circular motion. Uniform circular motion. What are those parameters? We discussed so many parameters. One of the parameters we discussed about angular displacement. Also we discussed about angular velocity, omega. Then we discussed about angular acceleration. Then discussed about radial acceleration. Then discussed about total acceleration. Then discussed about centripetal acceleration. Centripetal acceleration. Again, we discussed about centripetal force. Also, we discussed about centrifugal force. Centrifugal force, etc., etc., etc. Then in session 5, it was problem solving. Problem solving. So it's a problem solving of different questions to test your understanding about the formulas which has been established when we have been learning about parameters. Parameters, that actual parameters of 40 of uniform circular motion. So this is just to solve different problem. We had where the problem, and also we had different cases. Just remind you some of the mathematical formula. Remember that the relationship between linear acceleration and angular acceleration is this one. Relationship between angular velocity and the linear velocity is this one. Then the relationship between centripetal force or centripetal acceleration, the mathematical formula of centripetal acceleration is short. Is square of the velocity of r. Also discussed about centripetal force, which is equal to the centrifugal force, and centripetal force or centrifugal force, we say that this is equal to mass multiplied by the square of the speed of a radius r. So dear students, this is the quick review about what we've discussed in previous session. Today, let us discuss about motion in horizontal cycle. So the reference book that I'm using is called the Physics for Advanced Level Secondary School Students Book from 5 by Tanzania Institute of Technology or TAG. Motion in horizontal cycle. So let us define the terminology first. What is horizontal cycle? What is horizontal cycle? Define horizontal cycle. What is horizontal cycle? Before we discuss about motion in horizontal cycle, what's horizontal cycle? So this is the definition, simplest definition. Horizontal cycle horizontal cycle is the type of circular motion. Horizontal cycle is a type of circular motion whereby the body describes whereby the body describes what is circular motions, whereby the body describes a horizontal describe the horizontal, whereby I describe the horizontal cycle as its plane. So horizontal cycle is a type of the circular motion, is a type of the cycle whereby the body describes the horizontal cycle as a what? As it is as its plane. Then, after defining the terminology horizontal cycle, let us dive into the second equation. What is motion in horizontal cycle? What is the meaning of motion in the horizontal cycle? Excuse me. The concept of motion in horizontal cycle Wow, so it's a very good, interesting question. What is motion in horizontal cycle? The concept of the motion in horizontal cycle is defined or referred as one type of uniform circular motion whereby the body describes the horizontal cycle as its path and the plane. This is the simple definitions of motion in horizontal cycle. Dear students, say motion in horizontal cycle. Motion in horizontal cycle. So motion in horizontal cycle is defined as one type of uniform circular motion whereby the body describes or experiences the horizontal cycle as its path and the plane. The horizontal cycle. This is the horizontal cycle, and this is the vertical cycle. So this is the vertical cycle. So horizontal cycle is actual. The axis of rotations is perpendicular to the surface, while the plane of the cycle is horizontal. So this is the simple definition of the motion in horizontal cycle. Again, say motion in horizontal cycle. So after defining the terminology, the next step is it's the diagram. The diagram. Hello, Pre-Form 5, PCM, PCB, PGM, and PMC. Welcome into our TANZANIA Online Advanced Secondary School. So now, after learning about motion in horizontal cycle, introducing to you the concept, the definition, then we say that the diagram or representation of the motion in the representation of the motion in the horizontal cycle. In the horizontal cycle. How do we represent? By using the diagram, and also I will do demonstration. Okay? So how do you represent the motion in the horizontal cycle? So before we draw the diagram, we say that consider an object or a body, an object of mass m, tied to the end of the string, tied to the end of a string, tied to the end of the string, and it reeled in a circular path, reeled in a circular path on the horizontal plane. Tell your neighbor physics is beautiful. Tell your neighbor advanced physics is beautiful. Tell your neighbor mechanics is beautiful. So consider an object of mass m tied to the end of the string and reeled in a circular path on the horizontal plane. These are very important keywords because describe the concept of motion in horizontal cycle. So we are going to have a number, let's say 2 diagram. Suppose that this is the fixed end, and this is the fixed end for the string, and this is the other ends. So suppose that this is point O and this is point A. So consider an object of mass m while also an object of mass m. Let's say that this is an object of mass m before it is tied mass m before it is tied at the end of the string. So remember, this is the end, this is free end, and this is the fixed end. So this is fixed end of the string, and this is what? The string before the body, the object of mass m is tied to the at the end of the string. So now suppose that you still have, so this is figure 1 Roman A, the string. Then in figure B we still have a fixed end. This is another fixed end. Remember that the original length of the string before it is tied is this one. This is the original length. This is point O, and this is, let's say, point A. So this is the free end. So now let us tie the body or the object of mass m. No, it's not here. So before you release it, the particular small angle, then this is still a free end. This is still a free end. Then now we say that displace the string with the body to the particular, to the small angle. To the small angle. And then release it. Release it, not release, and then cause it to describe the circular motion. The horizontal, circular. So then it means that also on this side we are going to have something like this. So this is what we call it horizontal cycle. Horizontal cycle. Just to label the diagram, here we're going to have radius R, and then here we are going to have a particular height. while this one will be the actual length of the string. Remember, this is the string, still one string, but it is describing the horizontal cycle, and support that this is the directions of motion in horizontal cycle. But remember that I drew this horizontal cycle in two-dimensional structure. So this is what we call it horizontal cycle. It's not vertical like this way, but if you described or you disturb the body to describe the horizontal motion, then you'll find something like this. Remember that you have an angle there, then you have radius, and this is mass m. This is mass m. While the mass m will have its weight, which is mass times gravity. And remember that this is the center of the horizontal cycle. So, ladies and gentlemen, this is figure 2, the horizontal cycle, or the motion in horizontal cycle. So remember that by L is equal to length of the string. Yes, this is just a point. M is equal to the mass m. So we discussed about that. And theta, this is an angle. This is an angle. Angle described by objective M. So dear students, this will be our very interesting diagram concerning about motion in horizontal cycle. You can pause the video and draw it. So now, stop writing. While you are drawing, let me demonstrate. Demonstrate what is demo of motion in horizontal cycle. So how are we going to demonstrate? We say that we should have a string. Suppose that this is the string that I have. This is the OT, dear students. This is the string. And then suppose that this adapter head, it's OT, it's an object of mass m. So then I tie it at the one of the free ends, and then I can cause this mass m to describe horizontal cycle. So this is what we call it, horizontal cycle. I will teach you the next concept. I will teach you about vertical cycle. So this will be a vertical cycle. This is the vertical cycle. But horizontal cycle simply it means that an object will be describing a circular motion with the plane. So this is the plane. So the string will be making horizontal plane, and then the adapter's head will be actually describing horizontal motion. Have your own strings at home and find an object of mass m, n of them, and then tie it at the end and try to practice or demonstrate horizontal or motion in horizontal cycle. Is it clear? Is the concept clear? We have a lot of stuff that we are going to cover in this session. So then, if this is the case, so this string will not cut because they have a particular type of force that called the tension. Particular type of force that called the tension. So he said that, remember that this object describing the horizontal cycle, and I have told you in previous session that whenever an object is describing either horizontal cycle, vertical cycle, or actual moving that in a banked road, in banked smooth roads, then we'd like to ask you to make sure that you understand the cause of acceleration, the cause of centripetal force. Because centripetal force is always directed towards the cycle, toward the center of the cycle, while centrifugal are always directed away from the center of the cycle. So you have to understand about that, about tension. So remember that T standing for what? T standing for tension. R standing for what? R standing for radius. R stands for radius. Okay, so dear students, if this is the case, we say that tension, to apply the tension, to the string provides necessary centripetal force to the object so the applied tension to the applied tension to the string, the applied tension on the string provides necessary centripetal force to the object. So, if that's the case, so let us redraw figure 1D and write something. So this is the center, and this is the horizontal cycle. Also this is the semicircle for horizontal cycle. So it is elliptical structure, sometimes it is circular structure. It depends on the angle. So here we have angle theta. Then we say that suppose this is object of mass m. Object of mass m. So remember mass m, because it is on the Earth's surface, it will experience its weight, its own weight, which is measured as what? The product of mass and acceleration due to the gravity. So now when you want to show, remember that this is the string. This is the string. Then when you wanted to show about that angle theta with this weight m, remember that the directions of tension is always opposite to the directions of the gravity. So here we have tension T. Also here, so we'll be having tension and tension. So you may understand that the tension is described as oblique. So the tension has a vertical component, and also it has horizontal particles. So listen from here to here. R or radius. And this one is sorted. Horizontal cycle. Okay? Then remember that tensions is directed, or tensions has both horizontal component and vertical component. So it has a vertical component, then we're going to have tension, which will cause centripetal force, so that the object M will not cut. So this is the fixed end. Fixed end. Okay? So this is radius R. It is 2040 for tension. It's the relations of the upward force and downward force. Okay. So, is this the case? What do we say? We say that tension will be equal to the weight mg. Tension will be equal to mass times Figure 3. Figure 2. Figure 2 or figure 1? Figure 3. The motion of this tide stream, the motion in the horizontal cycle. Is the horizontal cycle. So tension is equal to mg, that's the figure 3, the medium, the motion in horizontal cycle. So remember that this is the horizontal cycle, and this is what we call it compound plane. Compound plane. So we'll be discussing about this, and this is the very mathematical important formula. Tension is equal to mass times acceleration due to the gravity. That's the mathematical formula, one of the formulas we'll be discussing. Okay, so just copy and draw the figures and label them. And then once you finish, we'll continue the next concept. Okay? Physics is beautiful, and you have to start. If you have joined us today, please check the subscribe button and just that. Dear students and dear serious PCM, PCB, PMC, and PGM students, make sure to have your pencil, because all the diagrams in advanced physics, we draw them by using the pencil. Then we have been discussing about the representation of the motion in the horizontal cycle, and our diagrams, very interesting diagrams, and we actually discussing about this diagram several times, and actually to explain this, because really remember that for this case we have 4 types of forces on this diagram. Okay, so how many types of forces do we have in figure 3? So in figure 3 we have, so if it's your first time to join us in our Tanzania online or A-level Seki school as one of our official YouTube channel for Tanzania Online Advanced Secondary School, and also if it's your first time to join us in Tanzania Online Full Technical College, we ask you to register yourself by clicking the buttons that written subscribe in order for you to receive notification whenever we publish a video. We always publish at least 1 video in a week, so make sure that you be a serious student and having a night prepper in our online schools or advanced secondary schools. So he said that there are, so let us discuss about figure 3. There are 4 forces acting on the objective, of mass m. So we have 4 forces here that acting on the objective mass m. The first force is what? It's weight. So number 1, we call that the first force is called weight of object. So this weight of the object, its actual describes as mass times acceleration due to the gravity. Then the second type of force in figure 3, which represent the motion of an object m in horizontal cycle. The second type of force is tension. So tension of the string, which is tension T. So remember the tension, the directions of tension is this one. So this is tension. Okay? This is the directions of the tension. Direction of the tension of the string. So it's oblique. It's neither horizontal nor vertical, but it is both. It has horizontal components. In tensions we have horizontal components and vertical components. Then the third types of force acting on object M is called the centripetal force. Centripetal force. So centripetal force, which is FC. So centripetal force, remember that what is centripetal force? Refer session 4. I taught you about very important parameter of uniform circular motion that called centripetal force. So centripetal force is the types of the force that is actual holding an object to describe a circular path, and it's always directed towards the center of the cycle, whether it's horizontal cycle or vertical cycle. So centripetal force is always directed towards the center. So this is not tension, excuse me. This is the radius. Radius is the distance from point O to, let's say that this is point O, point A, point B. Radius is the distance from point T or B, or distance between point O, B. That's the meaning of radius. But remember that horizontally, we are going to have very important types of force that called centripetal force. So remember that centripetal force is always directed towards the center. Remember that this is the center of center of the cycle. Nice. Pause the video and think a moment. Can you mention the first types of force that act on the object M? The first types of force is called the centrifugal force. So do you remember that? What are the directions of centrifugal force? The directions of centrifugal force. The directions of centrifugal force is always away opposite. It's always opposite. It's opposite to the center of the cycle. To the center of the cycle. So in case of horizontal cycle, these are the directions of centrifugal force. So these are the directions of centrifugal force. So how many forces acting on object M? 4. The first one, weight, or M, weight. The second one, tension. Tension, because this object is tied at one free ends of the tension, at the one free ends of the string. Then, so it will be tensions of 40 of the string. The third type of force is what? Centripetal force, which is directed towards the center of horizontal cycle. And then the fourth type of force is what? Centrifugal force, which is always directed away from the the center. If you have missed session 1, session 2, session 0, session 1, session 2, session 3, and session 4 and session 5 of uniform circular motion, you can access in the particular playlist which is called the uniform circular motion. In our official YouTube channel, Tanzania Online A-Level Circuit School, search uniform circular motion. You find sequence of sessions about these uniform circular motions, and I don't want to repeat more about this because we've discussed them at the key introductions concept, and now we apply them and see how do they affect the motions of the body in circular paths. So the students said that the only force acting on the object directing it towards the center is tension. So not before. Number 1, the only force acting on the objective of mass M is on the objective directing object of mass M, directing it towards the center of the horizontal, towards the center of the horizontal cycle, is tension. So this we call this what? Tension T. That's the first key concept that you have to note. The only force among the 4 forces, the only force acting on the objective of mass M, directing it towards the center of the horizontal cycle, is called what? Tension. It's not the weight of the objective of mass M. It's not maybe centripetal force, because remember that tension is the source of centripetal force, and then the weight actuals. So tension is the source of centripetal force, but also weight matters in this case. That's point number 1 that you have to note. Number 2, so you say hence the tension will provide the necessary centripetal force to keep the object of mass M in horizontal circular paths. So we say that hence the tension will provide, so the tension T will provide the necessary centripetal force, to keep the object in uniform horizontal, to keep the objective to this in uniform horizontal circular paths. Uniform horizontal circular paths. So this is the second point that to note. Dear students, remember these diagrams, very important, And we always, or in physics paper 1, you'll find the questions of uniform circular motions and can be motion in horizontal cycle, okay? So I had to keep the object of mass M in uniform horizontal circular path. Uniform horizontal circular path. Uniform horizontal circular path. So what will make an object of mass M to describe uniform horizontal circular path? It's tension, or it's force that called what? Tension of the string. So if that's the case, you say that mathematically now, this force, so mathematically we say that what is tension? So mathematically we say that from physics, we say tension is equal to mass times acceleration. And remember, this is equal to force because tension is actual, it's a one type of force. So mass times acceleration, and the center of tension is Newton. So this will be equation 1. But remember that an object of mass M describe what? Describe horizontal, uniform horizontal cycle. So the type, so the objective of mass M will have centripetal acceleration. Will have centripetal acceleration. So it means that we say that an objective will have centripetal acceleration. So this centripetal, just remind you, acceleration. So this centripetal acceleration, which is AC, is given as what? What is the formula for centripetal, for linear centripetal acceleration? It's the square of the linear velocity divided by radius of the horizontal cycle. So, dear students, if this is the centripetal force, and here we are going to have what? Centripetal acceleration is equal to the square of linear velocity over radius. So remember that tension of what? So tension T of mass M will be equal to what? Mass of object of mass M multiplied by what? Multiplied by centripetal acceleration. So you say that tension is equal to mass multiplied by centripetal acceleration. So this is equation 3, and this one is equation 2. So substitute equation 2 into equation 1. Substitute equation 2 into equation 1. So this is the first step of the derivation of mathematical formula, and then this the second step. So the second step, we say that substitute equation 3, no, equation 2 into equation 3. So in equation 3 we have what? Tension is equal to mass multiplied by centripetal acceleration. So mass multiplied by centripetal acceleration, which is the square of linear velocity over what? Over radius. So this will make mass times square of linear velocity over radius. So tension of the string will be computed mathematically by finding the product of mass of object and its square of velocity over radius of the horizontal cycle. Over radius of the horizontal cycle. So this is the first very interesting mathematical formula that serious students must know. Is it clear? Do you understand? Do you enjoy the beauty of uniform circular motion? Do you understand the way that I'm teaching you and the tricks that I'm teaching? I'm trying my level best to simplify the concept. So if this concept I've been introducing to you the concepts of motion in horizontal cycle, I believe that now you have understood this concept. Let us move into the second concept in session 60 that's called the conical pendulum. So now let me teach you about conical pendulum and be having the realization of mathematical formula that help to compute the period of the conical pendulum. Students say conical pendulum. Again, say conical pendulum. Say conical pendulum. So number 2, after explaining, after teaching you the concepts of motion horizontal cycle, number 2, I would like to teach you about what is conical pendulum. Conical pendulum. So what are we going to learn? Conical pendulum. Say conical pendulum. Again, say conical pendulum. So what is conical pendulum? So actually this is the type of the pendulum, it's a type of the simple pendulum which describe what? Describe a cone structure. Remember that we have a simple pendulum. We can demonstrate the simple pendulum that we taught you in physics Form 4, and also we'll teach you in simple harmonic. This is the simple pendulum. When we talk about conical pendulum, it means that the strings and object M will describe the conical structure, the structure 40 of the cone that you are used to enjoy it during your lunch or your breakfast. So, ladies and gentlemen, we have question 3. What is conical pendulum? Or describe briefly about conical pendulum. Or define conical pendulum. So a conical pendulum, we say that is a type of mechanical, so it is the type of mechanical pendulum in which the object tied at the end of the string and the wheeled, so and what? And wheeled and wheeled and wheeled and wheeled in uniform horizontal circular path of the string and drilled in uniform horizontal circular path, and its plane. On a horizontal plane. In horizontal plane. This is the simple definition of conical pendulum. So conical pendulum is a type of mechanical pendulum in which an object tied at the end of the string and railed in uniform horizontal circular path on a horizontal plane, or as HC plane. So conical pendulum is the conical pendulum. The conical pendulum is an example of motion in uniform horizontal the example of motion in a uniform horizontal cycle. Okay, so remember the structure. So the conical pendulum, they said this important sentence, the conical pendulum describes the cone structure. Conical pendulum describes the cone structure. This is the simple diagram of the conical pendulum. So do you see? It's a very good structure of cone. So then, here you have a head, and these cones will have an angle between the perpendicular lines and the string. Remember, this is the string, and here we have an object of mass M, and here we have verti. So separating, let us draw together. Here we have verti, center O, and the distance from O to A to B is verti, radius R. The distance from O to A is verti, the distance from O to A. So the distance from O to A will be discussed about that. Remember that the string will have length L, but also the string will have tension. And also here the string will have tension directly, which is opposite to the directions of the weight. The object M will have weight of mass M, and also the object M will have vertical or upward force, which depends on the resolving, and also mass M will describe verti, centripetal force, and also mass M describe verti, centrifugal force. So this is figure for the conical verti pendulum. Pause the video and draw it quickly. So that the simple diagrams of conical verti pendulum. So dear students, now let us derive the mathematical formula of period of conical pendulum. And we'll be following some steps. Derivation of the formula of computing the period of computing the period T of conical pendulum. Conical pendulum. We'll be following the number of steps on this derivation, and once we complete it, it will be the end of session 6. I will ask you to join me in session 7 when we'll have problem solving. So the derivations of the formula of computing the periods of the conical pendulum, because this pendulum, so it describes or it executes simple harmonic motion, or it means that it just repeats in the particular motion. So there's a period of completing one cycle or one horizontal cycle. So number 1, on the first step, we say that consider the object of mass M tidy at the end of string with length L and the tension T. So this are fixed ends operating. Check the diagrams, the one that we used to draw it. And then remember that before displacing it, so remember that this is object M, it has its weight mg. Then we have tension of the string, which is T, and remember that the length of the string is L. Length of the string is L. So we define length of the strings is L, the mass of the object is M, the weight of the object is mg, the tension of the string is what? T. So this is string. Okay? This is string. This is the fixed end. And this is the free end. So this is what? This is figure 5A. A free, simple pendulum. So for this case, the pendulum did not describe the uniform horizontal cycle or path. Then now, the second step, because we usually draw the diagrams of motion in a horizontal cycle while the object is describing the horizontal cycle. Second step, drill the object at small angle theta to describe conical pendulum. So reel the object in figure 4A above at the small angle theta. So what does it mean? This is the fixed end. So then this is the original length of the string. And then now we reel it, and it will be describing the conical pendulum. Then here you have center O, and then suppose that here we have object of mass M. So remember that we have tension of the string T, tension of the string T, and also we have length of the string, which is R. Also remember that object of mass M will describe or will experience the weight of mass times acceleration gravity This point is point A, and this point is point B. Here we have radius r. Radius r, the distance from the center of the horizontal cycle to point B. And then, now, we'd like to resolve. If you have a downward force, then we expect to have upward force. And the upward force will be tension. Remember that this is the small angle formed. The small angle formed the theta. So, how many forces act on mass M? 4. Weight, upward force, or tension, centripetal force, centrifugal force. So then, remember that this will be the direction of 40 directions of centripetal force. And this will be the directions of 40 centrifugal force to keep object of mass M in motion. So, if this is the case, then now we can resolve. So this is figure 5B, the conical pendulum. So here we are going to have horizontal vertical components, and here we are going to have also horizontal components in terms of tension. So if this is the case, then now we want to do to move into the second step, where that we have to resolve. The second step resolve vertical and the horizontal component of conical pendulum based on figure 5B. So what are we going to have? This is our vector diagram. This is our vertical components, and this is our horizontal component. And here we have mass or object of mass M. But remember that we have tension here. We have tension of the string, and this tension of the string makes an angle theta between the horizontal components and the strings. Make an angle theta. So if that the case, we can formulate a right angle triangle that will help us to find the, remember that the weight M also, the weight mg, and horizontal components will be like that ones. So the weight mg, horizontal components, vertical components, and remember that also we have this horizontal components will be equal to the centrifugal force. So this is figure 5C, the vector diagram. Vector diagrams of 40 of conical pendulum. So now, our interest is to compute horizontal components of force and vertical components of force. So this is the rectangle triangle, opposite side, adjacent, hypotenuse. But later on, remember that also here we have length. We'll be using length, so we have length. We have length of the string, don't forget. We have length of the string. We have length of the string. And here we have tension. So in resolving, we say that cosine of angle theta, this one, is equal to opposite, which is vertical component, opposite over hypotenuse, which is tension. So vertical components is equal to tension multiplied by cosine of angle theta. And this will be our first equation. So our vertical components, this one, it's 30, tension times 30, cosine of angle theta. So this is equation 1. Then the second equation for horizontal component. What do we say? Sine of angle theta is equal to it? Is equal to adjacent, which is horizontal component of force, over what? Of hypotenuse, which is t. Okay? So this will make 30, will make that horizontal component. Horizontal component is equal to tension sine of angle theta. And this will make equation 2. So the horizontal components will be equal to that ones. Vertical components will be equal to that ones. Then, do you love physics? Do you love advanced physics? Then, if this is the case, you still have some more equation. You say that first step. From figure 5C. What do you say that? The object of mass M will or describes the uniform circular motion, describes the uniform circular motion. The object of mass M describes the uniform circular motion. Object of mass M describes the uniform circular motion if 1. Centripetal force balances with horizontal component. What is centripetal force? Mass times square of linear velocity of r is equal to horizontal component. What's the horizontal components? Horizontal components is T or tension times sine of angle theta. So now we will have our third mathematical equation, which is centripetal force is equal to tension times 30 sine of angle theta. That is question 3. That is question 3. Question 4. The second condition for an object of mass M to describe uniform circular motion, uniform horizontal circular motion, is if the upward force balances with downward force. So this is the first condition. The second condition, we say the downward force must be equal with the vertical components of force. So the vertical components of force is equal to what? Must be equal to the weight. Then remember, substitute equation 1 into this equation. So then we'll find that tension multiplied by cosine of angle theta is equal to mass times acceleration due to the gravity. And this one will make question 4. You see the beauty and the applications of trigonometry in physics. Love mathematics for the rest of your life. So you have equation 4 and also you have equation 3. Let us move into the fifth step. The fifth step. So the fifth step, we say that let us take equation 3 divided by equation 4. So in equation 3, we have tension multiplied by sine of angle theta over tension multiplied by cosine of angle theta is equal to what? Is equal to mass times square of the velocity over radius, centimeter force, divided by mg. So when simplified, the equation on the right hand side, this will be equal to mv square over mgr. So m and m cancel. So this will have v square over gr. Then sine over, so tension over tension cancel. Sine over cos is equal to tan of angle theta. This is equal to what? Is equal to square of linear velocity over what? Acceleration gravity multiplied by radius. So this formula is very important. It can help you to calculate the angle of the compound pendulum. Also, this formula can help you to calculate the linear velocity of an object m. Also, this formula can help you to calculate the radius of uniform horizontal cycle. Radius of uniform horizontal cycle. So this is very important formula, and let me just write it properly. So we can have what? So in this one we can have that square of the velocity is equal to gr multiplied by tan of angle theta. You can just keep on simplifying. So if you are computing linear velocity of an object m, it will be equal to what? Square root of acceleration gravity multiplied by r, or radius of the cycle multiplied by tan of angle theta. So this is very important mathematical formula. Also, even this one is very important mathematical formula. Then remember that our final destination is to derive the mathematical formula of periods of compound pendulum. You can pause the video and write the notes until you finish. Students, do you understand? Do you understand? Wow. So now let us move into the sixth step. So the sixth step, we say that recall the relationship between linear velocity and angular velocity. Linear velocity is equal to what? Is equal to angular velocity multiplied by radius r. This is equation 6. Then we say that substitute equation 6 into question 5. So to substitute, so what is question 5 first? Tan of angle theta is equal to square of what? Square of linear velocity of an object over gr. So to substitute this, instead of square of linear velocity, we are going to have square of the products of angular velocity and radius divided by what? gr. So if you open the bracket, we are going to have square of angular velocity multiplied by square of radius of acceleration gravity multiplied by radius. So we cancel one radius with another radius. So tangent of angle theta is equal to what? This is the questions of physics paper 1. We just ask that, show that the periods of conical pendulum is equal to this. So then we have what? We have angular velocity square multiplied by radius over g. But again, remember that the relationship between angular velocity and the period. Angular velocity is equal to 2 pi over period. So this one will be equation 7. Substitute equation 7 in this equation. This is equation 7. And this is equation 8. Substitute equation 8 into equation 7. Tan of angle theta is equal to what? Is equal to 2 pi over period square multiplied by radius over acceleration gravity. Open the brackets, we'll be having 4 pi square times radius over period multiplied by acceleration gravity. Right? So tangent of angle theta is equal to 4 pi square r over g times period t. Make period t the subject. So to make period t the subject, you have to multiply by gt to both sides. Then now we can have periods of the conical pendulum is equal to what? Oh, this is period square. Period square. So period square. So period square is equal to what? Is equal to 4 pi square. 4 pi square multiplied by radius over g multiplied by tangent of angle theta. So find the under root of both left and right hand side. So now the periods of the periods. So let us record the square root of period square. It is period is equal to under root of what? Of 4 pi square r over g tangent of angle theta. So if you under 4, you get 2. If you under pi square, you get pi over under root of what? Radius of the uniform horizontal cycle divided by g multiplied by tan of angle theta. So one of the formula of periods of conical pendulum is this one. R g tangent of angle theta. Sometimes in some of the questions that we'll be discussing in session 7, you might be given a question and you'll be given a length of the string. The radius of the strings is not given. So then we can move further one step. Step number 7. We'd like also just to tell you that, remember the vector diagram. In vector diagrams, we had the length of the string at an angle theta. So then we have this. So remember that we had horizontal components and also we had vertical components. You remember about that? So now, how can we compute maybe horizontal components or vertical components in terms of 40, in terms of length? So it means that cosine of angle theta for this case is equal to adjacent of hypotenuse, horizontal components over L. So horizontal components is equal to length times cosine of angle theta. Again, another relationship which is very important. This is in case of horizontal components. But what if we are calculating or we are finding radius r? Radius r. Sine of angle theta length sin theta. How do we get length sin theta? So simply just, but radius r is equal to length times sine of angle theta. Substitute it there. Then have periods is equal to 2 pi under root of what? Of length sine theta over g tan theta over cosine theta. So this mathematical formula will be 2 pi under root of what? Under root of length cosine of angle theta over acceleration gravity. So another mathematical formula of periods of conical pendulum, it's t is equal to 2 pi under root of length cosine of angle theta divided by acceleration gravity. So this is another mathematical formula. So if you've been given length of the string, you have to use this to compute periods of compound pendulum. If you've been given radius, you have to use that. Dear students, is it clear about derivation? Maybe you did not understand it clearly, I've been moving very fast, or because it's your first time, maybe you just see during your O-level schools, it was actually spoon feeding, and maybe you can find that this concept is a little bit difficult. I want to tell you that the concept, these derivations, is simple. Please watch this video several times. Dear students, this is the end of session 60. I would like to take this opportunity to thank God who have given me this chance to be with you. And I would like to take this opportunity also to give thanks to you who have joined me in this wonderful and interesting session. So before we end session 60, I would like to join you by faith in order to give God thanks for the great thing that He has taught us today. Let us pray. Our Father who is in heaven, we come before your presence. We thank you for the good news that you have prepared in advanced physics, especially the part of mechanics, or the main terms of mechanics, and the topic of uniform circular motion. And you have taught your students the concept of motion in horizontal cycle. Thank you, Father, because you revealed the secrets to them, the mathematical derivation, and the entire concept. Let them bear this concept for the rest of their life and think about how to apply on solving real life problems. I invite you in session 7 when we actually having problem solving regarding sort of motion in horizontal cycle. Thank you, Father, and thank you for all the online community. We bless your name in Jesus' name. Amen. So thank you, dear students. I would like to appreciate you. Make sure that you register yourself into our official YouTube channel that's called TANZANIA Online A-Level Second School, and you can access our contents in terms of the playlist. We create playlists for subjects, playlists for topics, playlists for different concepts or particular concept. So make sure that you visit the playlist and you'll find the sequence of organized sessions of advanced physics, advanced chemistry, advanced computer science, Kingdom of Heavens, ufalme wa mbinguni, uje Tanzania, ufalme wa mbinguni, and also departments of advanced mathematics, advanced pure mathematics, and also you'll find a playlist of basic applied mathematics. So I'd like to thank you again and invite you in the next session 7. Share this link, these video links to other hundreds and thousands of PCM, PCB, PGM, and PMC advanced or pre-Form 5 and Form 5 students in Tanzania, so that they may enjoy learning advanced physics for the rest of their life. This is Mr. Olenjolai, a Tanzanian teacher who is really committed on just transforming the young minds in mathematics, science, and computer science. So natural science and computer science, in order to produce or in order to prepare the best scientists who will solve real life problems in Tanzania, and best engineers will solve real life problems in Tanzania, and the best mathematicians in the world. Thank you very much. In case you have a question, don't hesitate to ask in the comment section. Give us feedback in the comment sections, whether you understand or did not understand. Again, in case that you need to contact me, either on the normal text or call, or maybe on WhatsApp, please call me or text me or WhatsApp me through this number, +255 75 759 745 331 +255 759 74 53 31. Until we meet in the next session, keep enjoying the beauty of advanced physics. Welcome in problem solving of session 7. Is physics beautiful? Do you love advanced physics? Please let me know in the comment section. Me, I do love advanced physics for the rest of my life, and I will teach Tanzanians the beauty of advanced physics for the rest of my life. May God bless you until we meet in the next session.